This question, it says to graph the integral, and so what you would do is you would take your integrand of x and just find the graph of the y is equal to x. So here we have x, so we are going to graph y is equal to x. That's a linear function, so it's just going to be a line that has a y-intercept of 0 and then a slope of up 1 to the right 1, up 1 to the right 1. All right, so once you have your line drawn, then you want to look at the bounds that you have. So the bounds go from x is equal to 1. Remember, everything in this integral is involving x. So this is x is equal to 1 to x is equal to 5. So it's going to go from 1 up to 5. All right, now you of course need to find the top part of this, or the function value for this x is equal to 1. And to do that, you'll need to go over to the y-axis and find that y-coordinate. So really you can think about creating a little t-chart here where your function is y is equal to x and you're trying to find the y-coordinate for 1 and 5. So of course you're just plugging in and you'll get 1, 1, and then here you'll get 5, 5. Okay, and we are trying to find the area underneath this curve and above the x-axis. Now, when you look at finding this area, you're going to have to subdivide it into regions that you do know. So if you look, you can subdivide it into a rectangle and then a triangle. So if you look at the area of the rectangle first, the area of the rectangle is going to be the length times the width. The length from 1 to 5 is going to be 4, and then the width will be 1. So you'll just have 4 times 1, and you get 4 for the length, or for the area of that rectangle. That then needs to be added to the area of the triangle, which would be the 1/2 base times height. And the base here is going to be 4, because again, 5 minus 1 will give you the 4. And then the height, again, just be careful here, it's not going to be 5, because the height goes from 5 to 1, so that would be a total height of 4. So you're looking at 4 times 1/2 will give you 2, so 2 times 4 gives you 8, and that gives you that the total area would be 12 for that particular integral, and also for the area under the curve.